Now you're watching the educational channel on YouTube. By the end of this video, you will be able to answer the following problems. Problem 1. Phytane is the common name of a naturally occurring alkane that the IUPAC name for phytane is 2,6,10,14 tetramethylhexadecane. Write the line formula for phytane. Problem 2. Derive IUPAC names for A. Isomers of C4H10, B. Isomers of C5H12. Problem 3. Give the structures and IUPAC names for all the C5H11 alkyl groups and identify them as primary, secondary, or tertiary as appropriate. From the previous video, we learned that C5H12 isomers all incorporate pentane in their names are differentiated by prefixes of N, iso, and neo. Pentane, where we're now going to start learning about IUPAC rules, where IUPAC stands for International Union of Pure and Applied Chemistry. So hexane CH3CH2CH2CH2CH2CH3, where the bond line formula looks like that, can have isomers looking like CH3CH, CH2, CH2, CH3, CH3, and it has a pentane and a methyl group attached to it. So let's start learning the rules. Step 1. Pick out the longest continuous carbon chain. So here, 1, 2, 3, 4, 5 will be the longest carbon chain of it. Step 2. Identify the substituent groups attached to the parent. So we're now going to differentiate the substituent group and also the parent group, that from this molecule above, our longest group will be considered the parent group, and the one group that is not included in the parent group will be considered the substitute, or the substituent group. And we are going to name the substituent group as methyl in this case, which has a very similar structure with methane. And this is equivalent if you happen to draw, or if you happen to find your longest chain as 1, 2, 3, 4, 5, that is still pentane, the parent group, and that will be your substituent group, methyl. So they are exactly same structure. Step 3. Number the longest chain, continuous chain in the direction. So now we're going to learn how to number this longest chain. So we are going to number the longest continuous chain in the direction that gives, this is the key, lowest number to the substituent at the first point of branching. So let's see what this really means here. We were given this molecule, and if you name the carbon from 1, 2, 3, 4, then we have our substituent attached to the fourth carbon, where if you start counting from this carbon at the very left, 1, 2, we have our substituent connected to the second carbon, where this is lower than 4. So our parent chain, which will be labeled in blue, should start counting from the first carbon on the left so that we have lower number 2. So in this case, methyl group is attached to the second carbon in case 2. And in case 1, we have our methyl group attached to the fourth carbon. Step 4. Write the name of the compound. So the parent alkane is the last part of the name. And is preceded by names of the substituents and their numerical locations. And numerical locations abbreviated as locants. Hyphens separate the locants from the words. So this molecule is going to be named, or by IUPAC, to methyl pentane. There is no space in between methyl and pentane. 2 directs that the methyl group is attached to the second carbon. Another example, if we were given this, then the IUPAC name will be 3-methylpentane. Other remaining C6H14 are or that the IUPAC name of the left compound will be 2,2-dimethylbutane because it has double methyl group, we put a prefix di in front. That di represents 2, tri later will represent 3 same compounds or substituents, and tetra will represent 4. This compound will be named 2,3-dimethyl-butane because it has the longest chain and 1, 2 substituents at each second and third group. So let's go to problem 1. Phetane is the common name of the naturally occurring alkane that the IUPAC name for phetane is 2, 6, 10, 14 tetra. So we see 4 same substituent groups. And tetramethyl hexadecane represent number 16. So this molecule will have C16 and H something, where H will necessarily, if it follows the rule of the alkane, double the number of carbon plus 2, so that will give it 34. But actually the overall carbon is not 16, it's 16 from hexadecane plus the tetramethyl group, where the additional 4 carbons are, so it's actually C20H42. So drawing the line formula for phetane, I'm supposed to draw 16, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. And it has 2, 6, 10, 14 methyl. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this is how the line formula for phetane looks like. Continue with problem 2. The IUPAC names for the isomers of C4H10. There are only 2 isomers for C4H10. One looks like that, which we name butane, and that which CCC will be the longest chain. Let me actually label it with blue. CCC will be the longest chain, and the C labeled with orange will be the side chain. This is going to be propane, the parent group, and it has a methyl group at the front, and methyl is attached to the second carbon. So 2-methyl propane will be the IUPAC name. Isomers of C5H12 that I am drawing here. Pentane, two-methyl butane, two-dimethyl propane exists. Letter C, let's draw the line formula. I see the longest chain will be from C, 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 C. So it's a propane. And it has 1, 2, 3 side chain groups. So first of all, it's trimethyl pentane. So now we have to assign the numbers here. And if I assign number from this as a second carbon, then we will have 2, 1, 2, 3, 4, 2, 4, 4 tripentane. But now if we start assigning the numbers from this carbon, 1, 2, then we will have 2, 2, 4 trimethyl pentane, and because it gives the lowest numbers to the substituent at the first point of difference, the first point of difference is lower here, so we are going to choose this as the IUPAC name. C, C, CH3, 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 CH3 has the longest chain of C, 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 C. That's going to have a parent group of butane with 4 methyl group. So we shall name them a tetramethyl butane that has 2, 2, 3, 3. Either direction it goes, it has a symmetry, so it will be named 2233 tetrabutane. Okay. Now let's talk about naming the alkyl groups. Alkyl group selects one of the hydrogen of an alkane. So it has a very similar characteristic with alkanes, but it just misses one of the hydrogen. A methyl group looks like this. It's an alkyl group derived from methane. Unbranched alkyl groups in which the point of the attachment, which this is the point of the attachment, is at the end of the chain are named in IUPAC nomenclature by replacing ane endings by YL. So if it happened to be this, then it's going to be methane, but this A and E will be replaced by YL, that it's a methyl. And CH3CH2, that will be methyl. CH3CH2, 5CH2 will be haptyl group. The dash at the end of chain represent a potential point of attachment for some other atom or group. So at the end of this dash, you may have either a parent group or a possible other group attached to it. Carbon atoms are classified according to their degree of substitution by other carbons. So a primary carbon is directly attached to one other carbon. Similarly, A secondary carbon is directly attached to two other carbons. So this carbon is going to be considered a primary carbon. And it's a primary alkyl group. C, and H. This carbon has two other adjacent carbons that are attached to the carbon that we're interested with. It's going to be the secondary alkyl group. And as respected, a 3-carbon attached carbon will be considered a tertiary alkyl group. Ethyl, heptyl will be the examples for our primary alkyl group. And IUPAC name of 1-methyl ethyl group. Let's talk how it is methyl ethyl. So let's say this is where you're given maybe a parent chain. We usually use letter R to represent a parent chain, and you have CH3 to CH attached to it. Always the first carbon that is attached to the parent carbon will be considered number 1. In either direction, you have to assign number 2. Then this is going to be the substituent group. Therefore, it's going to be ethyl. But you have a methyl attached to the ethyl group at the first carbon. That's going to be 1-methyl ethyl group. And it has a very useful common name of isopropyl, because it has the iso and 3 carbon attached to it. CH3, CH2, CH2, CH2 group will be the butyl group. And CH3, CH2, CH3, this is 1-methyl propyl group, and it has a common name of sec-butyl. It's a 2-methyl propyl group. Has a common name of isobutyl. CH3, CH3, CH3 is 1,1-dimethyl ethyl group by the IUPAC name, and has a common name of terbutyl. Okay, let's go to problem 3. Give the structure and IUPAC name for all C5H11 alkyl groups and identify them as primary, secondary, and tertiary as appropriated. So C5H11, the simplest chain will be this, and this substituent group will be considered a pentyl group. And CH3, CH2, CH2, CH3 can have a R group attached to the second to the last carbon and will be considered 1-methyl butyl group. CH3, CH2, CH2, CH3, where the R group is there, will be considered 1-ethyl propyl group, because this is the longest chain to either direction, and now you're given an ethyl group attached to the propyl group. This is going to be considered 3-methyl butyl group, because we always have to assign the first carbon to attached to the R group. So the methyl group is attached to the third carbon. This case is going to be 2-methyl butyl group. The second carbon is that. This, the longest chain, is going to be CCC. So this will be named 1,1-dimethyl propyl group. And our last C5H11 alkyl group will be this. And the longest will be 1, 2, 3. So this and that are attached each to first and second carbon. So 1,2-dimethyl propyl group. Now let's assign an appropriate primary, secondary, or tertiary carbons. This is going to be a primary carbon because only one carbon is attached to it. This is going to be considered a secondary carbon because two carbons are adjacent attached. Another secondary carbon, a primary carbon, a primary carbon, and a tertiary carbon, and a secondary carbon.